Wow, wow, wow. This video has been a long time coming. All right. So ladies and gentlemen, welcome to this first video of this Zero to Deployment series, where the goal is to build useful and beautiful apps completely from scratch and then deploy it so that we can, actually download it on our phones. All the apps we're going to build are going to be completely open source, and you can find the link to the Play Store where you can download the app, and also a link to GitHub where you will find all of the source code to the app and the model and so on. So if you haven't checked out my introduction video to this playlist, then please do look at that one first, where I give a lot more information to the libraries we're using and why we're using those libraries. So specifically TensorFlow for our model development, and then Flutter for our app development, and also some just general thoughts on deployment, on cloud deployment versus on edge deployment, and so on. All right. So in software 1.0 land, you always start out with coding hello world, but for software 2.0, we got to step it up just a little bit. So we're going to build an app called Hello Mnist, and what it can do is it can identify a digit from an image or a drawing. And I think also that at the end of this video, you would recognize how training a model to do well on just Mnist dataset is very different from deploying that model. And we'll look at some interesting challenges, even on this very simple data set. But anyways, enough introduction. Let me show you exactly how the final app is going to look like. So this is the app right here. It's the best digit recognizer in the world. And then, so we have a box here which will display an image, and we have a current prediction. So if we press on this camera button right here, we can go to our gallery, and we can choose an image. So this one I've already downloaded, and then it will show the prediction for that image. And then we also have another tab where we can draw. So, we can draw a 7 like that. We can draw a 1. We can draw a, 0. And then let's see if we can convert it. All right, it doesn't work perfect yet. Can do a 3 or something. Yeah. So the overview of this video is essentially going to be split into 3 parts. So the first part will build the model in TensorFlow, and then we'll convert that model into a Tflite model. Then we'll build our app, and we'll integrate the Tflite model into our app. And then the last step, the third step, is to deploy this to the Play Store. Okay, so what I've done here is just created a completely from scratch project. And I should say that, I'm going to assume that you sort of know the basics of TensorFlow. So I might go through this a little bit quickly if you're not familiar with it. But that's just because this video is going to be really long anyways. And additionally, I also have, tutorials specifically on TensorFlow. And this is, I guess, more of an advanced video where we're actually, deploying stuff. So I might go through it a little bit quickly. So that was just a warning. But anyways, what we're going to do is just specify all the imports. So we're going to use OS. We're going to set TF CPP min log level because, I don't know why TensorFlow likes to give us all of these error messages. Is that your experience as well? That just every time you run TensorFlow, you just ignore all of those warnings? Anyways, that's what this does. It's just going to ignore those warnings. And then we're going to import TensorFlow as TF. We're going to use TensorFlow datasets as TFDS. And then TensorFlow add-ons as TFA, and that's just for some data augmentation that we're going to use. We're not going to use a lot of data augmentation. We're actually going to use very little, but you'll see that soon. And then we're going to import math from TensorFlow.keras. We're going to import layers. From TensorFlow, we're going to import keras. And then let's see. So we're going to do ds train, comma ds test, and then ds info. And we're going to get that from tfts.load. And the thing we're going to load first is just, we're going to specify the Mnist dataset. And then we got to specify the split, and the split is in the same order as this, as we said in this tuple. So the first split right here is going to be train. Second split is going to be test. And then we're going to shuffle files equals false because we're going to shuffle them later on anyways. And then as supervised, we're going to set that to true. With info, we're going to do true on that. So, yeah, so I guess let's just do some skeleton code to just sort of see what we're going to do. So we're using wrapping it in a TF function for some optimization that TensorFlow can do for us. So that's a very easy thing to do. Then we're going to normalize image. We're going to send in an image and a label. But for now, let's just return image and label. We're going to do a similar thing for a TF function, define augment of image comma label. And we're going to do do augmentation here. And then, we're just going to return image and label. And let's see. So after the augment, all right, so we're going to have that normalize image, we're going to have that augment, and we're going to do, map those to our data set. But let's just do our data set first, and then we'll implement those. So first, we're going to specify autotune, which is tfdata.experimental.autotune. And then batch size is going to be 32. And so for our training data set, we're going to do first dstrain.cache. We're going to do dstrain.shuffle, and we got to send in a number here. So let's just do dsinfo.splits of train, and then num examples of that. All right, so then we got to map our normalized image and our augment. So map, let's see, normalized image. And here we can do some optimization. So we can do number of parallel calls, and we can just send in that auto tune that we created above. And I guess we can do the same thing for our augment. And then we're gonna batch. So .batch of batch size. And lastly, we're gonna do just a prefetch. So prefetch, and again, we're going to send in auto-tune. So that's for the training data set. For the test data set, it's going to be a little bit simpler. And all we're really going to do there is map that normalization. So normalize image, and then num parallel calls is auto-tune. And then we're also going to do ds test and batching. So batch size, and then that prefetch as well, ds test dot prefetch of autotune. Okay, so yeah, so let's implement that normalize image and augment. But what we're going to do then is define our model that we're going to use, and compile model. Model.fit, and then model evaluate. So that's all we're going to do. And after training, we want to convert to Tflite model. And then that Tflite model we're going to use inside of our app that we're going to build. All right, so normalize image. What we're going to do there is pretty simple. We're just going to do tf.cast our image to a tfloat32, and then we're going to divide by 255. So making sure that images are between 0 and 1, which is just a common normalization in TensorFlow and in general, I guess. So here for data augmentation, we're gonna do image is tf image, or actually, let's see. We want to first just make sure that it's in the correct size. So size of that image is 28 by 28. It should be by default, but let's just make sure. And then we want to rotate that image. So we could do, we can get some degrees. So rotate image. We're gonna first just get some random amount of degrees, and actually this might complicate things. So let's just do image is rotate of image, and then so we'll create that function. So we'll do add tf function, define rotate of image, and for now let's just return image. And then after that we'll do some random contrast and brightness of that image. And why that is a good thing in this case is because when we take a photo, the background might not be completely white or black. It might be a little bit different. So just making sure that it's robust, relatively robust to those. So what we do is that we do image, then tf image dot random brightness of that image. We specify a max delta, let's say of 0.2. And I haven't tested this extensively. You can probably do a lot better here, but we're just gonna do some random brightness, and we gotta do some random contrast of image, and then let's specify lower, let's say 0.5, and upper as 1.5, and then we'll return image. So this is just a random color coloring of image, and then here we'll just rotate. So for the rotation, we want to first create a random integer of the maximum amount of degrees, or the degrees we want to rotate it. So let's specify the max degrees to be 25, and then we gotta do just a random integer value. So tf random.uniform, and we're just going to send an empty list because we just want a scalar that is in between max degrees, negative max degrees, and max degrees. And the d type here we'll set to tfloat 32, and then I will rotate the image. So how we do that is by doing image equals tfa dot image dot rotate image, and then we need to send in a value that how much needs to be rotated, but that's gotta be in radians. So we gotta convert the degrees to radians. So how we do that is we do degrees times math.pi, and then we divide by 180, and then we'll set interpolation to bilinear, and that should be it. And we'll just return that image. So that's our augment, that's our rotate normalize image. Hopefully you're following so far. It's not going to be anything complicated really, for this at least. So then we're going to do inputs. And again, here we're just creating a very simple CNN model. You could probably do better. I'm sure you can do better, but this is just a simple model that works. So the shape is going to be 28, 28, 1. We have one channel because it's grayscale. And we'll do layers.com 2D. We'll have 32 channels, and we have 3 input channels. So we'll send that, we'll send in inputs through that layer, and then we'll do batch normalization on that. And we are also going to do activations .relu on that. And then let's just do a max pooling 2D, and that's default gonna have a stride of 2 and a kernel size of 2. So that's max pooling. We're gonna do, I guess we're gonna use the same thing. So let's copy that, and what we're gonna change here is that we're gonna have 64 and then 32. Just making sure. No, sorry, that's gonna be 3 for the kernel size. So we're just gonna use the kernel size of 3 again, and then one more time. Yeah, so we're gonna copy those, we're gonna paste those again, and we're gonna do 128 channels or filters for that comp. And then we're gonna remove that max pooling, and then we're gonna do layers.dense 64, and actually between those we have to do layers.flatten of x, and we'll do 64 output nodes on that fully connected layer with an activation of relu and sending x through that. And then outputs, it's just going to be layers.dense 10 output nodes because we have 10 digit, and then activation is going to be softmax. So after that we do return keras.model, where we specify the inputs as inputs and the outputs as outputs. All right, so we'll do model equals my model, and we're then gonna compile our model. So model.compile, let's set a loss function of keras.losses.sparse categorical cross entropy from logit equals false, because we have a softmax right here. And so why we're using a softmax on the output here is quite important, because otherwise, so that means that it's going to be part of the model that we then export to Tflite. And if we then, when we make our app, when we run the model, it's already going to be, softmax on the end, on the last final layer. So they're always going to be normalized, which is nice because we don't have to do that in the app. So that's why we do it that way. And then, all right, so for the optimizer, we're just going to use Atom. So optimizer is keras.optimizers.atom. Learning rate is going to be 1e minus 4. We're just going to use that as default. We're not going to do any learning rate schedulers or any of that stuff. And then metrics is just going to be accuracy. Then we'll do model.fit ds train. We'll set the epochs to, I think 20 should be enough. And verbose equals 2, so it doesn't print all the time. And then model evaluate ds test. And lastly, we're just gonna model.save model. All right, so that was less than 80 lines of code, and hopefully no errors. Let's see. This will be a first if this is no errors. Wow. Okay, it doesn't work. Yeah, flatten. There you are. Flatten. Hopefully this works now. No, I can see an error. Okay, so far only one error because I caught down one. So this is going to be capital M. All right, so I forgot to add two things, which is these two lines right here, which is we're checking the physical devices for the GPU, and then we're setting a memory growth on the GPU. So if you are running on the CPU for some reason, then you don't have to add those two lines. But if you are on the GPU, this helps. This helps sometimes to just not get any CUDA errors. But all right, so after we add those, let's go back and let's change the number of epochs a little bit to 30 instead. And now we can run that model. Okay, so after 30 epochs, for some reason we don't get that good of an accuracy, and I'm thinking it's the augmentation, probably. So it should be very easy to get over 99%. And I don't want to tweak too much with this because it's not really that important, I would say. But yeah, it should not be hard to get over 99%. And that's what I got before. So I'm not really sure what I've changed because I got 99.2 running this before. Maybe it's the batch size or it's the data augmentation that I've changed. Not really sure, but I don't want to retrain it because it takes some time. So let's just take that model and convert that model to a Tflite model, and then we'll use that inside our app. But I think that I'm actually gonna take the other one that I had because that one got a little bit better accuracy. So let me just create a new one, a new Python file, convert to Tflite. And then what we're gonna do is first of all, we're gonna import TensorFlow as TF. I'm gonna specify the saved directory, which is just model. And we're gonna do a converter. So that's gonna be tensorflow.lite.tflite converter from saved model. And then we're gonna specify the saved directory. All right, so if you haven't converted to a Tflite model before, you essentially have some options. If you just do it naively, it's going to be a float 32 precision, which is what the model was trained on. But it might not really be necessary when you're just performing inference to have float 32. So what's common is to convert it, when you're converting it, also reduce the precision and make it into a float 16 model. And what that will do is it will reduce the memory size of the model, which is important when we're building an app, right? Because we don't want it to be too large when people download it. So float 16 is going to half the model size, and it's also going to run a bit faster. And then people have even taken this further and then do something called quantizing the model, which is taking instead of having float 16, you're reducing it to integer. And so I don't want to go into too much depth on how they do that, but it's pretty awesome because they reduce the memory size by 4, and then they also make it run 3 to 4 times faster, which is very nice when we're running on the phone, right? But what you can do when you're converting it that way is that you can lose some precision. So what I usually do is that I convert it to a float 16 model and just make sure that it works, and then see, is speed an issue here? And if speed is an issue because we have a very large model or something like that, then I would go further and quantize it. And be careful that you're not losing too much accuracy when you're doing that. Yeah, and then the last thing I'm going to say is that even if you are losing some accuracy, you can do something called quantize aware training. So that would, we would have to change our training setup to do this quantize aware training, but in that way we lose less accuracy when we're then converting it to a quantized model. All right, so what we do anyways is that we do converter.optimizations, tf.lite.optimize.default. You can specify more here, but we're just going to use the default settings, and then converter.target. We're going to specify supported types to tf.float16, and then model light is converter.convert. So they've made it pretty easy for us. Just those couple of lines, and then with open model.tflite. WB as F. We're going to do f.write model light. And that's all we need to do. Not really sure where we're getting an error here. But yeah. What is there here? Statement. Does it have to be this way? Not really sure. Let's try to run it and see if we get an error, because that's pretty weird. Oh, I'm blind, sorry. All right. I was looking at that for like 20 seconds, but didn't see it. All right, so now we got, when we ran this, we got our model.tflite. All right, good. So now we've done part one of this, of the building our app. We're now gonna move on to Flutter, and we're gonna use that model.tflite inside there. All right, so now we're at the step 2 or part 2 of this video, where we're gonna build the app in Flutter. And of course, for that, you have to install Flutter first. So I'm gonna not actually show that because I don't think it's very difficult, but I'm gonna link this in the description, and then you can just come back to this video when you've installed that. And also, this is a video tutorial by the Net Ninja, who has other Flutter tutorials as well. But yeah, if you just follow this video, it's 12 minutes long, and then you're good to go. So assuming you've done that, we can now open up Android Studio. And what we're going to do is we're going to create a new Flutter project. And we're just going to do a Flutter application. Next, and we're going to, let's see, this should be, all right. So let's see, our Flutter SDK path should be right there, Flutter. And let's call this hello Mnist, like that. It already exists. So let's do hello underscore Mnist. And then next. And this is fine right now. This is sort of the ID of the app, which has to be unique. So we might have to change that later on, but let's just keep it as is right now. And now we have that created on our desktop. So let's just wait for this to load. All right, and make this full screen like that. Beautiful. So first thing we get is sort of a default project. And, you know, we can open up our emulator and we can just see how that looks like. So, all right, that's our app, but let's see if we can run this one instead. All right, so this is what the demo app looks like, and we'll take a look at this in a little bit more detail. But first of all is that I'm not assuming that you know Flutter from before. And I'm not sure if building this app that we're going to build is going to be too challenging for some of you, you know, as a first app. But I just want to say that if you don't understand everything, that is, you know, completely okay. And, you know, to be honest, when I built the app, I didn't either. I just Googled a bunch and even followed other tutorials on how to do it and so on. But what I'm going to do is I'm going to try to explain everything so that you at least understand what's going on and what we're doing. And hopefully I do a good job at that. But if it's difficult, just remember that, you know, this is, you know, hard, and we're building an entire app from scratch as our first thing that we're doing. So if you don't follow along with everything, that's completely okay. And all right, so this is just what, when we run this, this is what we get. And we can click on this button and it'll just say you've pushed the button this many times, and it'll increase as we push it, as we press it. So that's the app that we were giving at the start when we create a default project. But I feel like this can be very difficult for a beginner. So I'm just going to remove all of this stuff and let's keep that. All right. So first of all, now we can, you know, yeah. So this is going to be removed. We're just going to have a completely from scratch app. But let me first explain just this folder setup that we're given as a default project, and say that you can ignore everything except the lib folder, right? So the lib folder is where our entire project is going to be in, and everything else you can safely ignore for now. And this, I guess one thing is that this right here, this test thing, is if you want to do tests on your app, which we're not going to do. So we're just going to remove that directory entirely. And yeah, so let's see. What we want to do is I'm just going to create sort of what the structure of the things we're going to do and how it's going to look like. So remember that I said that all we care about is this lib folder. We're going to create a directory or a package, which is called, let's say, DL_model. That's where we're going to keep track of everything related to our deep learning model. Let's create a new package and let's call that pages. So we're going to have different pages to our app. If you remember in the beginning, you could see that we had sort of two different tabs where one was, actually, let me bring that up. So, all right, so here we go. So in the beginning, we had two different tabs right here. We have a draw page and we have an image page. So those are the two different. When we press this one, we get to that page. And when we press this, we get to that page. So, so that's what we're going to have in that folder right there in pages. Then we're going to have another one, which we're just going to call utils, I guess. We're going to keep track of constants and so on. That will make more sense as we go along, but just know that this is the basic structure right now. What we're doing here is that in our main file right here, we're importing material.dart, which is, we're going to do that in every file that we create because we want to be able to use material design that Flutter is built upon. Just know that we're going to import that every time. And then the main function is going to be called at the root of the Flutter app. And what we're doing then is we're doing run app, and what we're running is my app, which we haven't created yet, which is why it's giving us this red, error right there. And if you're familiar with coding in Java or something like that, this should, this is going to be easier. But otherwise, this void right here is just saying that the main function that we created is just not going to return anything. All right. So what we want to do is we want to create my app, and what we're going to do is create that class my app, which is going to, so let's do that first of all. And I'm going to use a shortcut, which is stateless, and that's going to create a class for us. And I'm just going to call that my app. All right. So that's sort of just some boilerplate code. And if we rerun this now, it's going to be completely dark. So there's not going to be anything in our app. So we created a class my app, which extends from a stateless widget. And so this is sort of the basics of Flutter, in that everything is built on something called a widget. So let me bring out the app that we're going to build. So this entire, the entire screen is built of a widget as a sort of a parent widget. And then that parent widget has children in that it has sort of, for example, right up there, it has sort of it's called an app bar, which is a child widget of this parent widget, which is the entire screen. Then we have, some text written right here, which is another widget, the text widget. We have sort of this box right here, which is another child of that parent widget, and that widget right there is called a container, and is what we'll build upon so that we can draw inside. Again, this button at the bottom right is also a widget. And so everything is built on a widget in Flutter. And if you don't know exactly what that means, that it's okay. But a widget is essentially what builds the graphics. And everything is built upon widgets. So we're going to have a very large tree based on widgets at the end. then for widgets, we have two different types of widgets. We have stateless widgets and stateful widgets. And basically, very simple. Stateless widgets are if the page is never going to change, and stateful widgets is if the page is going to change. So for example, here when we're drawing, we're changing how the page looks like. And even here, we're updating based on what we drew. So this is going to change depending on that, which means that it's a stateful widget. It's going to change the page. Wow, okay. Maybe this was harder than I thought, but hopefully you're following so far. So we created my app, which extends from a stateless widget, which is that it's not going to change. And what we're going to do in this is we're going to return something called a material app. And this is just, we're always going to return a material app. So let me just set up the basic structure. And what we're going to have there is a home screen, right? And this, all right, so let's see. All right, so we're always going to have a material app, and we're going to set a home screen to be home. Now for the home screen, and what we want to build first of all is just this screen where we can change, we can press these two buttons right here. In that we can press this and we get that tab, or that the screen associated with pressing here, and then the page associated with pressing here. And so our home is going to be a stateful widget. So instead of doing stateless, we're going to do stateful to get a stateful widget. So this is just some boilerplate code that we get from doing that, and we're going to call that home. And in our home, our parent widget that's going to be, where everything is going to be built upon, is going to be called it's called a scaffold. And you can read more about this, but hopefully, so we haven't created anything. All of this is just syntax of how we structured the initial part of the app. So we're going to return a scaffold. Which is the main, you can view this as the main parent widget. So now we get this white screen, and what we can do in this is that we're gonna have a list of different tabs. So we're gonna have a list of tabs, and what we're gonna do, so this is the list that we've initialized right here of tabs. What we're gonna have is we're just gonna have a text. And we're going to do, this is image page, and then we're going to have another text, which is going to be the drawing page. All right, so we haven't created those yet. Those are just going to be text for now. So for our home page, we're going to return this scaffold, and the body that is containing, what is contained in the scaffold is going to be tabs of some current index. All right. And, yeah, so I definitely should have made a simpler app. I'm realizing that now, but hopefully this is still something you're able to follow with. So we're going to create an integer, which is a current index. We're going to set that to 0 as default. So at the start, we're going to have a body, which is going to be tabs of current index, which is 0 at default. So we're going to, as in initial, we're going to show the image page. All right, so I don't know if that is going to show anything. Yeah, so we can see that the text showed at the top left, which is, it says image page right there, which means that the body is showing what we wrote here. Now, that looks kind of ugly. I would want it to be in the center. So as I mentioned before, in that everything is built on widgets, we can wrap this widget. If we just, keep our cursor right there, we're going to get this light bulb right there, and we can press that, and we can see that we can wrap this widget with other widgets. And that is building, again, that tree of widgets where we have, scaffold at the top, a child of that is a text widget, and now we can wrap that text widget with another widget. confusing at the beginning, I know. But so we can wrap with a center widget, which means that if we now rerun it, hopefully it should now be at the center. So now we can see that the image page has been, centered. So that's the initial page that we have. But now we want to build, we want to be able to change between those two. So we're going to build a navigation bar at the bottom. And that's actually a child property of scaffold. So bottom navigation bar is going to be another widget, which is bottom navigation bar. And we're going to keep track of that, sort of the current index. And the current index is just going to be the current index, which we initialized at the top here. So the current index, let's see if we run, if that is going to show anything right now. Oh yeah, we're going to get an error. So, all right, so what we want to specify now is what items we're going to have at our bottom navigation bar. So for that, we're going to have a bottom navigation bar item, which is another widget, a child widget of this bottom navigation bar. And so the icon of that, we're going to do icon and then just do icons.image. So this is just an icon that is given to us by Flutter. And then we can set a label to that. And let's just do image. So that's the first bottom navigation bar item. We can copy that and we can do, instead of doing icons.image, let's do, I don't know, the first thing, let's do album. That's the first thing that comes up. And then let's do draw. So let's see if that looks anything different. And after doing the entire app, I noticed that I was covering the bottom of the phone because I'm an idiot. So right here, when I'm doing the bottom navigation bar, let's see where I was doing that in the main file. Yeah, when I was doing the bottom navigation bar item and I was wanting to show how this looks like, this is how it looks like. So whenever I am covering this, then just imagine that that's how it looks like. And if you're coding along, then it should be easier, I think. All right, continuing with the video. So, all right, so we've created a bottom navigation bar, and to that we have items, where we have two bottom navigation bar items. And we've set image and we've set draw. So when we press on that right now, we can see that it is a something that's clickable. It's reacting when we're clicking, but nothing is changing on the page. And so what we do there is that we need to define on tap. So on tap is going to be a function where we're going to get some input to it, and we're going to get an index as input. And that's just how this bottom navigation bar works. It takes, when we press something here, we're gonna get an index given to us, and then we can, inside these brackets right here, we can specify what's going to happen when we get that index. And so what's going to happen is that the current index is going to be set to index. So when we now control S on that, we can see that, all right, we can do, let's see, print current index, and we can see, you can see it says 0 right there. And if we press here, it says 1, right? And remember that this is why we did a stateful widget, because it's going to change depending on what we press, right? When we press here, we want it to change. We want the screen to change. So what we got to do then in Flutter is that we got to do some set state. So that means that we're updating the state of the screen, which is possible because we've built a stateful widget. So inside here is actually where we want to do the current index equals index. So what happens is that when we're tapping this, we get an index given to us by this bottom navigation bar, and we're setting a state. We can do that because we're in a stateful widget, and we're updating current index to index. When we're doing it inside set state, that's going to refresh the page, and we're going to now since current index is now updated, it's gonna rewrite the screen, and now hopefully tab should be of the changed current index. So let's try that. And what happens is that, all right, we press this one. Now we get to that page. And again, we see draw image at the top left, barely visible. And what we can do is that we can, again, wait for that to show up, and we can do wrap with center. And now we should see that it says drawing page at the center of this, hopefully. All right, so it says image page. When we press on draw, it says drawing page. All right, so I mean, now we've created the basics right here, but there are some things I want to change with it. And you know, what we're gonna do later on is we're gonna, inside this this pages directory that we created, is where we're gonna create two new pages. You know, where we're gonna have the draw page and the image page. But so I want to customize this page just a little bit. So first of all, I don't really like, I would like to have, let's see, I want to have a selected font size. So I want to change that, let's say 14. So this means that this right here is going to change when we select it. The font size is going to be 14. And then when we press something now, the text is sort of becoming larger, and I don't really like that, so we're going to change the unselected font size to be the same. And so you can see now that when we're jumping between those tabs, the only thing that changes is the color, and we're going to change the selected item color to be colors.pink. And so now it shows a pink color instead, and when it's unselected item color, we're going to change that to be colors gray. And so when we do that, we can see it like that. And one other thing you can do is you can sort of change the sort of what is it called, like how strong gray it is, like the weightness of that of the gray, I guess. And so what you can do is you can do in brackets, you can specify. So let's say we do 800, that's going to be pretty dark gray. But if we do 100, it's going to be it's barely visible now. But I found that, you know, just playing around with this, 400 looks pretty good. So we can still see it, but it's, you know, this one definitely takes all the attention. All right, so that's the initial page, and hopefully you're following so far. So what we're going to do is we're going to create the upload page, or the image page. I don't know why I called it upload page, but anyways, we're going to call it upload page. So that's going to be inside pages, and inside that we're also going to create a drawing page, right? And then in that the DL model, we're going to create another Dart file, and we're going to call that classifier. So classifier. And so we're going to implement that later on, but let's just start with the upload page. And in the upload page, we're going to import material.dart. Yeah, so let's create a stateful widget, stateful, and I'm going to call this upload image. And inside this page, I'm again going to return a scaffold as our parent as our parent widget, so to say. And we're going to specify a background color to that. Let's do colors.gray of, I don't know, 200. And let's see, or let's do red actually, so that we can see that something is changing. So what we got to do now is in our main file, we're going to import, let's see, package, hello Mnist, and then we're going to import pages. And from pages, we're going to import the upload page. All right, so we're importing that file that we just created. And then instead of having this tabs right here of image page, we're going to change that to upload image, which is kind of a bad name when I think about it, but yeah. All right, so now when we press Control Save, or at the top right, the screen button, we'll see that the background has changed to red, which is what we want, right? That's all that we've done so far. But perhaps we can do a gray background instead, just slightly gray. So yeah, so what we want to have also is that we want to have an app bar. That's the app bar is what's going to be shown at the top here, right? That's the pink thing right here where it says best digit recognizer in the world. So that's a sort of a property of scaffold. We can do app bar, and we can do app bar widget. And to that app bar, we can set a background color. So we can do colors.pink. And now we can see that we've created that app bar. And then we can set a title to that as well. And the title is going to be from a text widget. And let's just write best digit recognizer in the world. And that's what it looks like. So now that we have the app bar, we have the bottom navigation bar. What we want is, well, when we look at it, we want to have first a text, then we want to have this box right here, and then we want to have some text, and we want to have some additional text. All right, so one of the most common widgets is a column widget. And as you can see, everything right here is sort of aligned in a column, right? So what we can do is we can specify a body to this scaffold, a body, which is going to be a column. So that's a column widget. And this column is going to have a bunch of children. It's going to have, first of all, it's going to have this text, then it's going to have this box or this container, another text, and another text. So inside this column, we're going to have a text like that. And let's just write image will be shown below. Then so what's the error right here? Oh, right. So we need to specify the children of this column. So this text is going to be a child to this column. So we're going to specify children of this column. All right. So now we can see that this text is shown right there. And then we can do a container like that. And let's see how that looks like. A container. Let's have we can specify the height. Let's do 200. A width. Let's do 300. And then we can do color. Let's do colors dot blue. All right. So that's what it will look like. That's where our box will be later on. And one thing I don't really like now is that we don't have that much space between the text and the container. And if we look at the image right here, we see that at least there's some text, right? And so what we can do, an easy fix to that, is using something called a sized box. All right, there's a lot of syntax, a lot of different things that I'm sort of throwing at you right now. And if retention is not that high, that's okay. But at least you're understanding what we're doing, right? We want to create some space between that. So a simple way to do it is creating a size box, and we'll specify the height of that. So a height, let's say 10, that looks pretty good. And we can see that we've now created some space between that. One thing that's different from how we did, or how that image looks like, is that the text here is larger. So a property of this text widget is that we can specify a style of that text. So the style is going to be a text style widget. And inside that text style, we can specify the font size. So let's say, 30, but that looks a little bit too large. So let's change it to, see what I did before. 20, yeah, 20. So that looks pretty good. And all right, so then below this container, we want to have another text where it's going to say current prediction. Again, this is too close to the box. We want it to be, quite far below that. So we're gonna have first a size box between the container and that text, and we're gonna specify 45 to be the height. And yeah, we're gonna do a comma right there. So all right, so now we created some space between the container, but we haven't specified. So let's see, we need to do style again. So style, this is going to be a text style again, and here we're specifying the font. So we're gonna, font size is going to be 25. And as you can see, when I'm just pressing F, you can see that there's some different things here. You can do font style, font family, all that stuff. So for example, we can do font weight. Let's do font weight dot bold. So that'll bold that text right there. All right. And then let's see. So we want, let's see if I just like that. All right. So we have a text style to that, and we now have that text. So we then want to have the prediction. So let's do another size box because we want some space. Yeah, and by the way, don't think that I'm so pro at Flutter. I'm totally garbage at Flutter, right? I'm not good. I'm just showing you how I created the app. And for those of you who know Flutter, you're like, why is he doing that? Then, please make a comment and I'll try my best to improve. I'm just sharing what I've been learning about. So we're creating that size box, and then we want to have a text for the classification of that digit that we uploaded. So let's just write 5 right now. And again, let's specify the style. It's going to be a text style of font size. Let's do 50. We want that to be really large. And again, let's see. And then font weight. Font. Sorry, this is the font size. This is the font size. And then the font weight is going to be font weight dot bold. All right, so let's see now. All right, that looks pretty good. And one thing though that's bothering me a little bit is that, first of all, I would like to have some space between the app bar and the text at the top. So at the top here, we're going to do a size box, and we're going to specify a height of 40. So what that'll do is just push it down a little bit. And one thing that's annoying me a little bit is that this should be centered, right? And one thing you can think of is that we could wrap this with a center, and that'll work. That's not what I did at the first time though. But center seems to work, so we'll keep it at that. All right. Now we want the color of this container to be white. All right, so what we can specify now for now, we can do a decoration. We're going to have a box decoration. Inside the box decoration, we're going to specify a border, and we're going to do border.all. We're going to specify a color, the color of that border, and border.all is just that we want a border across the entire container. And then the color is going to be colors.black, and then the width is going to be, let's say, 2. Oh. Right, so you can't specify a color when you do box decoration. Then that has to be inside here. So we can do like that, I believe. And that should hopefully work. Yeah. So now we have sort of this border showing, which makes it a little bit clearer in my opinion. All right, so now we've done sort of the default layout of the app, and yeah, let's see what's a good thing to do now. First of all, we want to have a button here, and a way we can do that is we can do a floating action button. So that's going to be a floating action. Let's see, floating action button. So we want to, in our floating action button, we want to have a background color, and let's do colors.black, and let's see if that works right now. Right. So a button has magically appeared. And I don't know about you, but all of this still seems magical, that you can just do this and a button will magically appear. It's like, I don't know. Anyways, so what we'll do, we'll create a child to that, and the child is going to be an icon. And the icon, we're going to do icon, and then we'll do icons.camera. Yeah, just camera. And that's how it looks like. I don't really like that icon, so I've just looked around and I found this one to look a little bit better. All right, so I mean, we've now created what the app looks like, right? But we've not created any of the functionality. Meaning, if we press this button, if you press this button, nothing's going to happen. So, and also, we can't upload an image. This current prediction is not associated with running any model. So that's just the UI of it. The user interface. So I guess, yeah. So what we're gonna do is we're gonna need some packages. Wait, did I write that? I don't know how that got there. Anyways, so in this pubspec.yaml file, this is where we import packages, this is what we sort of say which packages that we're gonna need for this app. So right now it just says a bunch of information, and if we scroll down, it says here dependencies, and in the dependencies, all that we're having right now is this Cupertino icons. That's just what we get from out of the box. So let me see. Let me try to write all of the packages that we're gonna need so we don't have to bother about them later on. So we're gonna use, first of all, Tflite _ Flutter. And this is going to be, we're writing caret, I think that's how we pronounce that, right? 0.5.0. And let me show you how I got to that. So if we go to pub.dev, this is where all the packages associated to Flutter is. Now you can just write Tflite. And we can see that we have some different packages to run a Tflite model inside Flutter. And this is the library that I've chosen to use, Tflite Flutter. And he has some instructions on how to use it and so on. But he also has installing. So installing in dependencies, we just gotta write we just gotta copy that, and then we can go to our app, we can just copy paste that in, and then at the top right, we're gonna press that pub get, so that'll download that package. And actually, he also has some additional instructions where if you're running it on, if you're running it on, for Windows, you got to place a script as well at the root of your directory and just run that. And that will automatically download and place binaries at appropriate folders. So, wait, I feel like I'm confusing the hell out of you right now. Yeah, so we're going to use that later on, right? We're not going to use that now, but we can do that nevertheless. If you go to that page, you can download that install.bat that he had, and I already sort of have that. So I'm gonna just copy paste that into our folder right there. So we have that windows.bat file. And if you're on Linux or Mac, just follow the instructions he had, and it's going to be in the description. So if we just press that, it's going to download what we need for Tflite. All right, that's for the first package, and that's perhaps the most difficult one. Then we're going to use something called image picker, and that's why we got here in the first place. So we're going to use a package called image picker, and what image picker is going to do is allow us to either take a photo from the phone or upload a photo. So we can go again to installing, we can do image picker, and we'll just copy paste that image picker right there. And I'm going to copy paste the other ones that we're going to use as well. So we're going to use something called image. We're going to use image as well. And this one we've already done. So we're going to use one image, and then we're going to use Flutter launcher icons. That's for having an icon to our app later on. And then change app package name. We're going to use that later on as well. But yeah, this one, image picker, is the one we're going to focus on right now. So we're going to get all of those. Then let's go back to our main file, and we'll get this pub spec has been edited. We'll we'll press that get dependencies. And now we should have all of the packages that we're going to use for our app. And yeah, so what we want to happen now is that when we press the upload page, when we press on this right here, we want something to happen. And specifically, we want to be able to choose a photo from our gallery. So a property of this floating action button is on pressed, right? So this is a function which takes some input. In this case, just nothing as input. I remember that previously for our main file, we did similarly on tap, which was a function. It took an index, and then inside those brackets right there, we did some stuff inside that function, specifically set the state. But so here we're just on pressed, we're not getting anything, and then right here we're going to specify what's going to happen when that is pressed. So when that is pressed, we want to do first of all, we need to instantiate the picker. So the picker is going to be an image picker. So this is going to be image picker. And I guess we need to also import picker.dart. Right. So image picker is image picker. So we're calling image picker, and we're calling that picker. One thing you can also do, instead of specifying the exact sort of, I guess, type of what we're instantiating, we can write final, and this is going to be, I guess, sort of not actually sure how that works exactly, but final is that we're instantiating that once. So I guess that whatever type image picker is going to become that type, and that will be sort of the final type of that one. And in that way, the type is more dynamic, because if this was an integer like 5, then this would still work. But if we would do something like it's going to be an image picker, and we specify this to 5, we're going to get an error because, a value of int can't be assigned to a variable of type image picker. So what we do here is final picker equals image picker, and it's going to be whatever type that is. For those of you who are more knowledgeable about this, I'm just used to Python, all right? So I don't worry about types too much. But that's how we do it. And then we're also gonna specify we can do that so far. So our picker, when we run this on pressed, we want to do we want to get an image, right? So we want to do picker.getImage, and we want to do that from some source. And what we do here is we specify image source, and then we can specify .camera or gallery. And I guess both works for this project, but I'm just gonna pick the gallery. So and also you can do 2 different action buttons. We're gonna do that in later projects, but so you can specify that you can take from the camera or the gallery. So you have 2 buttons for that. But for now, let's just do a single one. And when it's sort of I guess when it's sort of something to be executed, you write this semicolon at the end instead of comma. So we do picker.getImage from source image source.gallery. Let me just stop this and then rerun the entire thing. So it's going to rebuild our project. All right, so when we press that, it says allow hello Mnist, which is our app name right now, to access photos and media on your device. We're just going to press allow. And right now, yeah, so on this, I uploaded this file previously. So I guess we can press that one. But, as you can see, nothing happens. But at least, we can access the gallery. And then what we can do is we can write a image that we're going to take from that, which is going to be a picked file. So when we the type that when we pick a file inside of the gallery using this picker library is return something called picked file. So we're going to do picked file and we'll call it image. So what we'll do is we'll do image equals picker.getImage. Now, one thing here is that when we do things like this, when we set image equal this, but this thing right here is not guaranteed to return something immediately, right? The user might press, wait a while, a really indeterminate time before they actually pick something. And so what we want to do is we want to wait until the user has picked something. So how we do that is something called asynchronous functions, meaning that when we do a wait, image is not going to be set to this instantly, which gave us that error. It's actually going to wait until the user has chosen something and then set that to our image. All right. And then what we want to do here is we want to do, classifier.classify image of that image, but we'll do that later on. But so this is what we're going to do later on. When we get the image, we're going to run our model on that image. And one more thing we need to do is we need to do set state, and we're just going to do set state like that. And what's going to happen here is that we did this picked file image. When we're setting set state right here, that image that we picked is going to get updated. And why we want that to be updated is because we want to show that image right here. Let's see what the next step is, what the best next step is. So yeah, so what we want to do is inside that container, remember that container we created that the image will be shown inside. We want to have an image to that box. And so what we specify is that in that box decoration, we specify something called image. Now, this is kind of, I would say, a little bit tricky. There's probably better ways to do this. I've managed to get one way to work, but I'll explain the problem first. So, obviously we don't want anything to show until we've uploaded an image. But when we've uploaded the image, we want something to be displayed here. So the image at the beginning, we want just to be a white, just a white color. But we can't do colors.white because this is not an image, right? It needs to be of type decoration image. And I'm kind of embarrassed to do this because this is not a good way of doing it. But yeah, most of you probably don't know Flutter, so you're not going to judge me. But those who do is going to judge me. So what I did is I used something called a ternary operator. And basically, well, I'll show you what that looks like. But first of all, basically, I downloaded a white background image. So we, just Google a white background or something like that on Google and download it or something like that. And what I did is that we're going to create a new directory. We're going to call that assets. I just downloaded a white background and I'm just going to, so let me show you this white background, and it's a white background.jpg, and that's all it is. All right, so I'm just going to drag that into that assets folder that we created right there, and that's the white background. Okay, so then we're gonna go to pubspec.yaml, and we're gonna specify that we had that, we created that folder. So let's see, we got to go to our pubspec.yaml. We got to go down to assets right here, and we're going to remove that comment. So we're going to do like that, and then 2 spaces. We're going to specify that we have an assets folder. All right, and then we got to do pub.get. And now get dependencies. And now for our upload page, we're going to specify that image. So we're going to do asset image. And we need to specify where that is. It's in assets, and it's a white. This should, yeah, I don't know. Let's see, white background dot JPEG. I'm not sure really what the error is here. Right. We need to wrap this. So this will just remove this for now. And we need to wrap that in a decoration image. So that decoration image is going to have an image. A little bit confusing, I know. I just Googled, and that's how I found it out. So here we're going to specify the asset image. And for that asset image, we can now, restart the app, and nothing will happen, right? Because we've now just changed the white color to a white background image. And you're probably wondering why I did that. So what we're going to use is something called a ternary operator. And so we're going to specify another thing right here. We're going to do int digit, and we're going to set that to -1 to default. And that's what's going to get returned from when we classify that image, right? We'll get an update of what that digit actually was when we run our Tflite model. So inside here, we're going to check, is digit equal to -1? Question mark. Is it equal to -1? And we know if it's equal to -1, then that means that we haven't run our model yet. So that means that we just want to show a white background. And, right, so this white background right here. But if it isn't, right, if it isn't, so we'll do that colon, if it isn't, then we want to show the image that was uploaded from the gallery. And how we do that is we'll do file image of image.path. Looks hella confusing, I know, but that's how we do it. So at the top here, we're going to do dart.io or dart.io. So we're going to import that package, and that allows us to get this, hopefully, this file thing right there. All right, so let's see if we need to restart the app or if this works. So actually, let's just change the digit here. So let's do digit equals 1, and let's see if we can rerun it. And then again, upload the gallery, press that. And as you can see, that image was now displayed inside that box. Beautiful. Exactly what we wanted. So yeah, let's keep it like that for now. And then also we want to specify that this integer right here, it says current prediction 5, is going to get updated as we, let's see. Yeah, we want this thing right here to be displayed depending on what the model gave us as output. So how we do that is we do again a ternary operator. So we'll check is digit equal to -1 question mark. If it is equal, then don't show anything. But if it isn't, that means that we've updated our digit, because the digit is always going to be between 0 and 9 inclusive. So it's then what we'll do is we'll then display that digit. And how we do that is we reference that variable, that integer, by doing $sign and then digit. and then we'll do a comma right there. All right, so let's Control S, and you'll see that this get updated to a 1. Let's just do that this digit is now 3, and let's do that. So after we get an image from the gallery, we run this, and the digit is set to or actually let's set it to 7 because it's a 7, right? Assuming the model is correct. So press this, we press that image, we upload that, and then the current prediction gets changed to a 7. Of course, this will happen every time, but later on we'll create the classifier that will do that depending on what's actually in the image. Yeah. So for the classifier, we're gonna import material.dart always. We're gonna import Tflite. We're gonna import Dart.io, and we're gonna specify that as IO. And we're going to import image.dart, and we'll see if there's more. There's probably more. Yeah. Anyways, what we'll do is we're going to create our classifier, and we got to do sort of the init method as we do in Python. I'm assuming you come from Python as I do. And how we do that when we create a class is that we basically do it this way. Actually, I don't want to go into that right now. Let's do it. It's going to be empty anyways. So this is how you do just an empty one. In future videos, I'm going to go into that in more depth. But anyways, so what we do now, we're going to do classify image. That's a function we're going to create. It's going to take as input a picked file image, right? That's taken from the gallery. All right. This is going to be asynchronous because sometimes when we're performing inference from the model, then we need to wait for that until we obtain our results. So there's going to be some waiting involved. That means it's going to be an asynchronous function. Now, this is actually going to be much easier in future videos. So in retrospect, this was a difficult one to start with because the image is grayscale. And unfortunately, the library doesn't have that good of sort of a default loading of grayscale images. So I kind of have to do it manually, but this makes it, the solution I came up with is pretty ugly, but it works. So I'll show you this, but just keep in mind that it's going to be simpler in future videos. So, and there might be better ways to do this as well. And if you know a way, then make a pull request or something on GitHub. That would be very appreciated. All right, so we have that pick file, that image. What we got to do first is we got to convert that to a file. So we're going to do io.file of image.path. And let's see, I think we can just do file. No, we can't. Oh, io.file. Yeah, that works. But if you're lazy, I think this is the better way because you're specific. But if you're lazy, you can just do write var. It's meaning that it's going to be a variable and it's going to be dynamically changed to whatever this is set to. All right. And we're going to import this image as img. So then we're going to do img.image, and we're going to set a temporary image. Actually, this is nonsense. So let me just copy paste this crap because this is just after Googling, and I'll explain what we do here. So this is after Googling a bunch, and what happens here is that, all right, we have this picked file image, right? But what happens is that we need to convert this into a list of values. And what we also need to do is we need to resize this image to be 28 by 28. All right. So so to resize it, we need to convert it to a file. Then we need to decode that image, that file, to an image. Then we need to do copy resize. So that's why we decoded it as an image, to be able to resize it to 28 by 28. Now that we have it resized, we need to get it as a list. So we do get bytes on that resized image, and then we do dot buffer as uint8 list. And yeah, so we're just going to do ugly boilerplate to get it to, yeah, I guess uint8 list, right? So that's some, you can ignore this, all right? Don't look at it. All right. So when we have it, our image as a list, we'll run another function. So we'll do return get prediction of image as list. So everything important is going to be inside this get prediction. All right. So we're going to create get prediction. It's going to take as input a uint8 list, image as a list, and we're going to do some stuff on that. So first of all, we're going to do a list, which we're going to call result bytes. It's going to be a list of 28 times 28 in size. And then sort of an issue that we get when we load this image as a RGBA image. And so it reads the red color, the green channel, and the blue channel. It also reads another one, the alpha, which is the opacity of the image. That's not necessary for us, so we're gonna ignore that. But obviously we want this to be a grayscale image. So a way to do that is just to take the average of all of those channels. So what we do is we do create an integer index to set it to 0. Then we'll do a for loop. So a for loop of int I equals 0. So we'll start at I equals 0. We'll continue until I, so this is the termination criteria, how it's called, image as list dot length in bytes. I think you can just do length though. Let's do length in bytes. And then we'll do I plus equals 4. All right, so what we're gonna do inside here is we're gonna take the average of those RGB channels to get a grayscale, just a grayscale output for that single channel. And we're doing 4 here because we're gonna skip the alpha, the opacity channel. All right, so we'll do final R is image as list of I, and let's copy that 2 times. Final G, final B, this is I plus 1, and this is I plus 2. Then we'll set this result bytes of index to be the mean between those. So R plus G plus B. We'll divide that by 3, and then we'll also divide it by 250 for the normalization. All right, let's just continue. So we're gonna do our input is gonna be result bytes, and this is gonna be a 28 times 28 list, but we're gonna reshape that, and luckily there's a reshape function that's given to us by Tflite Flutter. So we're gonna resize that to 1 28 28 1. Right, we have 1 is our batch size and 1 channel, and the output is going to be a list that's 1 times 10, and then we'll reshape that to be 1 comma 10. Right, that's for the output. Then we'll create some interpreter options to be interpreter options. Yeah, so I'll copy the Tflite model and I'll just put it in assets. All right, so that's the Tflite that we created before. So I just copy pasted in the assets. So now we have the model.tflite from before. So what we're doing here when we're creating the interpreter options is that basically you can choose to run the model on the GPU, on the phone. So I'm just including it here, even though we're not using it, so that you know that it sort of exists. All right, so then we're gonna do a try except, or in Flutter, this is try catch. And I guess, yeah, I don't want to confuse it too much. So try catch, and then interpreter. We're gonna create an interpreter. This is so that we can run our model, and we're gonna do await interpreter from asset, and we're gonna specify model.tflite, and then options, interpreter options. All right. Now we're doing await because it might take some time to load a model. So we're gonna create this to be an asynchronous function, and it's gonna return an integer digit, I guess. Yeah, no, it's just gonna return integer like that. And because we're using this asynchronous, we gotta specify this is gonna be a future integer. So it's gonna take some time, but in the future, sometime, we don't know how long the model is gonna run and so on. But in the future, an integer is gonna be returned, which is gonna be the predicted digit from this this image that we send in. All right, so we're loading the model, we're creating an interpreter from that. And the catch is we're gonna print in just error loading model or running model, like that. And what we're gonna do after we've loaded the model, if that is successful, we're gonna do interpreter.run on input and output. All right. What's going to happen then is that everything is going to be stored in this output. And yeah, so that's this right here. Now what we want to do is we want to sort of go through that output and make sure that it or check what the final prediction was. So we're going to do double highest probability. We're going to set that to 0, and then we're going to do int digit prediction. So we're going to go through every in that list. So we're going to do for loop. We're going to start at 0. We're going to continue until we're at the so we go through every of that 10 values, those output, which has gone through a softmax, by the way, because we included that in our model. So that's going to be normalized probabilities. And then we'll do I++. And why we're doing 0 here is because we just want a single list of 10 elements, but it's returned as a 1 by 10. So if we do index it by 0, we're just going to get 10 elements. So that means that we can index it easily. So we'll check if output of 0 and I, if that is greater than the highest probability so far, if that is the case, then we'll change the highest probability to equal that output. And we'll also change the digit prediction to I. Okay, so we did that, and then at the end of that for loop, we hopefully get the digit prediction. So we'll just return digit prediction. All right, so we've created all this code. Let's just review it quickly. So we first get a picked file image from the gallery that we pick. We do some ugly stuff to convert it to a list, including that we have to resize it and stuff like that. Then we call this get prediction, which takes this list as input and returns an integer for the prediction of that image in the future, because it's an asynchronous function. We instantiate or we initialize a list, which is 28 by 28. We go through this because it's loaded as an RGBA image. we go through it and we average the RGB channel. So we divide by 3. We then skip the 4th index because it's the alpha, the opacity channel. Then we are reshaping it to match the input size of the model. And you can try it out if you do something else here, but the model is going to give an error. The output is a list of 1 and 10. And then here we create some interpreter options, but we don't set it because, so we could just as well ignore this, but it's good to know that it exists. Then we try to load the model from our asset folder, and it's going to be model.tflite. Then we try to run it with the input and output. And if it doesn't work, we catch that with a catch block. Lastly, here we just check what was the best accuracy, which is the prediction of that one. And that's it. Yeah. So then let's go back to our upload image, and now we can create our classifier. So we're gonna import package hello Mnist, and then deep learning model, and then classifier. And then we gotta create our classifier. So this, we're calling it classifier with a lowercase c, and it's a class classifier. So we're gonna just initialize that, and then when we wait to get our image, we're then going to run classifier.classify image, and we send in that image. So that's the digit. And I think we probably need to just restart the entire app because we changed so many things in the app. All right, so now when we press this, we'll get this image, and when we press that thing, we get an error right here. We need to wait until the classifier is done. So here we need to do an await, and let's see if it works. And it seems to work. And remember, this digit right here now, the 7, is actually from the model because we're doing classifier.classify image. We have now created the upload page, right? That's when clicking this, and we will have the image right there. Now we're going to create the draw page. So the drawing page, let's see here, we're going to create, we're going to import material.dart as always, and we're going to import package Mnist, hello Mnist, deep learning model, and classifier. All right, then we're going to create a stateful widget, and remember the shortcut, stateful. It's going to be called a draw page. Inside the draw page, we're going to have a scaffold, and we're going to do some very similar things. We're going to specify background color. It's going to be colors.gray of 200. And now let's see if this is changed. All right, so we might need to do that. All right, yeah, so here in the main file, we're also going to import this drawing package, hello Mnist, pages, drawing page. And then for our second tab right here, we're going to replace that with the drawing page, the draw page, yeah. So let's check now. If we press this, it doesn't work. All right, so we need to restart the app again. But anyways, inside this, we have the background color. We're going to specify a floating action button. And I think we can copy paste a lot of stuff from what we did previously. You know, the floating action button is going to be pretty similar, except that it's not going to do this thing. So on pressed, we're just going to remove that for now. So all it does is it's a floating action button. It has a background color, and it has a child. And here we're going to do cross, I think. Let me check what I did. Close. Yeah, close. So now if we press draw, we get to this page and we have that floating action button. Actually, we can keep that on pressed. We're gonna do as input nothing, and it's gonna do nothing. So when we press this, nothing is going to happen. But what we are going to do now is we're gonna create a an app bar, and we're gonna create the same app bar as we did over here. So the app bar right there. Oh yeah, one thing is pretty nice is that you can do, let's see, Control Alt. Wait. Oh, that worked. All right. So yeah, Control Alt L, and that'll auto format your code. You can also press Control Shift Alt L, and then you can specify what you want to format. But yeah, that's pretty nice sometimes. So we'll create the app bar in a very, exactly identical to what we did before. So now we have that app bar. We'll create a body, and this is going to be a column. And that column is going to have some children, and it's going to have some pretty similar stuff. And I actually think we can copy paste what we did there as well. But for good practice, let's do it again. So we're first going to have our text. We're going to do draw digit inside the box. Now that is too small font, so we're going to specify a style. Text style, we're going to specify the font size to be 20, like that. And we're going to do a size box above of height of, let's see what I took, 40. I'm going to do a comma afterwards. All right, so we're creating some space from the app bar at the top and then some text. All right, then we're going to do a container. The container is going to have a height of 300, a width of 300, and it's going to have a color as, I don't know, let's do blue as we did before at start. All right, there's our box. Now we want to have some size, some space between that text and the other one. So let's do a height of 10 right there, and a comma. So that looks all right. Then afterwards, we are going to, let's see. Yeah, so let me actually now, okay, so I think you understand what we're doing. We're doing the same thing as before. So we have the box here. Let me copy paste. Afterwards, we're going to have a size box. We're going to have current prediction, another size box. Then we're going to have some text. So let me copy that in and see what it looks like. So we can just write text 5 for now. And like that. And let's see. So we have container, we have a size box, we have text current prediction, and we have a size box and then the prediction. So if we run that, this is what it looks like. And now it's blocking some of the stuff. Yeah. All right. Then, we wanted this centered because it's not nice to have it like that. So we'll wrap it with a center. You can do that by pressing Alt Enter and then wrap with widget. And then it's one as default is wrap with center. You can also have the cursor marked and then you'll get this thing right there. You can do wrap with widget, and then you can also write the widget that you want. And now it should be centered. Create, first of all, at the top here, we're going to create our classifier is classifier. And we're going to initialize that classifier class. Then we're going to do a list. It's going to be a list, and the values inside that list are going to be offset types. This is just because that's the type when we're drawing on this thing right here, this container, it's going to be points that are of offset type. We're going to call that our point, and that's going to be just a list of offset. we're going to initialize that list like that. So, list, a simple list is just that. And then we specify that the values inside that list are going to be of type offset. All right, then we're going to do int digit is -1 as we did before. All right, so what's going to happen is that when we press this thing here, we're going to do points dot clear. So we're going to empty that list, and we're going to set digit to be -1. So that's going to reset the page, so to speak, reset the prediction. Then for our prediction right here, we're going to do a check if digit is -1, question mark. If it is, just have an empty string. If it's not, have the digit. All right, and it's -1 at start, so it's going to show just that. And yeah, I feel like I'm now just not doing the hard part. So the hard part, and this is perhaps not going to make too much sense, I guess. We'll see. We're going to create a decoration. It's going to be a box decoration. It's going to be colors.white. The border is going to be border.all, as we did previously. It's going to be a black border, and the width is going to be 2. Right, and we can't specify the color there, so we got to do it here. So what we want to do is want to do a child of this box decoration, and the child is going to be a gesture detector. Sorry, it's a child to the container. Yeah, so child to the container is going to be a gesture detector. Why we need a gesture detector is because we when we're drawing inside this container, it needs to be able to detect where we actually are in the container. So we're going to have a gesture detector, and what that is going to do is on pan update and on pan update. I guess that's I'm not really sure what the abbreviation is for, but what it's going to do is that when we're inside this and we're pressing inside this container, we're gonna do a function, and what we're going to get is drag update details is going to be the type, and then details. So the details is going to include sort of the location of where we were clicking inside or drawing inside the container. Okay, so what we're doing is offset, right? Remember, that's what's going to be inside of that list. So the offset is going to be a local position, and the details is in the that local position is included in details.localPosition. Then we're going to do set state, and we're going to do points, that list that we did, add local position. All right, so if we, I guess, print points, that's our list. When we press in here, you can see that it has added a bunch of these points, right? When I was clicking inside of that container. Obviously, it's not showing in the container, but they are getting registered or getting added to that point, to that point list. Okay, so what we're going to do next is, this is when we're on pan update, but what we also want to do is on pan end. So when we're dropping, so when we're pressing here and then we're releasing the button, so we're not drawing anymore, then we're also going to get some drag update details, but it's going to be drag end details like that. And what's going to happen there is that we're going to call we're going to do something, and we're going to add points.add null. So what we're then doing is updating our digit, and we're going to do await classifier dot classify, and then we got to do classify drawing of points, which we haven't implemented yet. So I'm just going to out comment that so far. But that's going to be points that add null. Okay. Now the child of this gesture detector, and now we're really building that tree of widgets that we're talking about in the beginning. The child that's going to be a custom paint. And then we're going to have a painter. And the painter is going to be a class called painter, which we're going to create. And inside this painter, we're going to send in points. So we're going to create that at the bottom. So at the bottom here, we're going to class painter, and it's going to extend from that class called custom painter. Okay, so we're going to have a final list of offset points, and this is going to be sent in to our what I view as the init method of the class. So if you're familiar with Python, so we're going to do painter, and then inside this we're going to do this dot points. All right, so we're saying that, you know, we're going to have a final list of offset points. And I think you can actually just do that. Yeah, but we can do it like this, and we're gonna call it points, and this is also going to be sent in to this painter, right? That's what we did at the top here. Points, we're sending in the points that we have gathered so far when we've added the local position of where we're drawing. We're then doing final paint, and then paint details is equal to paint. So what we do here is that we're specifying how the paint should look like of when we're drawing. So we're going to specify that this style, and we're just going to do painting style dot stroke, and then we can specify things like stroke width 4.0, sort of the width of when we're drawing, and then color is colors dot black. Yeah, all right, so we're missing some stuff. We're missing specifically the paint and the should repaint. So let's do those. This is, you know, two functions that is included in this custom painter class, and we're just going to override those. So it's not going to return anything. So we're going to write void, and we're going to create the function paint. It's going to take in a canvas, as we're going to call canvas, and it's going to take in a size, which we're going to call size. Okay, so what we're going to do is we're going to go through every of those points in our list, right? This points list. And so for int I equals 0, and I is less than points dot length, and then -1, I plus plus. Then we're going to check, so we're going through the entire point, every offset point that is in that list. We're going to check. All right, so what we're going to do is we're going to do canvas.draw line between points I and points I plus 1. And we're going to send in the paint details there. Why are we getting that error? But anyways, it should hopefully be fixed when we do the last thing, which is should repaint function. Here we got to send in, not really sure what this is, to be honest. I'm not going to try to explain it, but we're just going to return true there. So basically that should repaint. All right, so I think I found the error. It should just be equals here. Yeah, so let's try that and see how it looks like. We should be at the draw, and then now we should be able to draw. There's just one issue, which is that if we draw, say we draw a line there, and then we draw a line there, if we remove that, so we're not adding null, and then we draw a line there, and we draw a line there, you'll see that it draws a line between those 2 points. But it obviously should not do that. You know, if we draw a line there and then we want to draw a new line there, it should just draw two lines parallel to each other. So for that, we need to add a point null when we sort of release the button, right? So now we've released it, right, on pan end. And then when we release it, it's going to be null. So then we want to do a if statement here. We're going to check if points of I, if that isn't null, and the point that it's trying to connect it to, where it's going to try to draw the line between, if those two are not null, then we can do this, this draw line right there. So if we now update that, hopefully it should work. We'll see that we can now draw two like that without it connecting those two, which is, you know, exactly what we want. Yeah, and here we notice a problem. See here that I can't start to draw outside the container, but I can draw inside and then I can draw outside, which is not what we want, right? We wanted that when we get to the edge of this, we don't want to get be able to draw outside. So for that, we need to add this point only if it's within the container. So, you know, more specifically, we need to check if the local position dot x, if that is greater than 0, and the local position, let's see, if the local position dot x is less than 300, which is the size of our container. And we do the same thing for local position dot dy greater than 0 and local position dot dy less than 300. All right, so then if that's the case, then we'll update the point. Control S, let's see if it works. So now we're going to get to our image. We'll go to our draw page, and then we'll see if we can draw outside, and we can't. So now we're bounded by this container, right? Which is exactly what we want. Okay, perfect. So now what we want to do is we want to call our classifier. So what we're going to do here is we're going to create another classify drawing. And to classify drawing, we're going to send in a list of offset points, which is going to be those points that we recorded, just points. So we're going to send in a list of offset points called point. It's going to be an asynchronous function because we're going to have to wait for some stuff. And then this is going to be some boilerplate code. I'm going to copy paste that. So, you know, ugly boilerplate to get it to uint8 list, similar to what we did before. So let's see. That's the code right there. And this is going to be 28. And then we got to implement that to picture function. But when we've done that, we want to return get prediction of image as list. Okay. So now that we have that, so what we're doing here, basically what we're going to do, we're going to take our points, we're going to create a picture out of those points, and then we're going to convert that picture to an image, and we're going to resize it to 28 by 28. Then we're going to convert that to byte data, and we're going to get that, then get that to a uint8 list. We got to import, let's see, import dart.ui as UI. No, dart:/UI as UI. And then we're gonna do, oh, okay. So picture UI.picture. And then let's see, we're gonna do toPicture. And we're gonna take as input a list of offset points called points. And what we're gonna do here is that, recognize that when we're drawing here, is that the background is white and the color of the digit is black. And this is a limitation of our model right now, right? The training data of Mnist is black background and then white paint. So basically, we're going to repaint the entire thing. I'm gonna copy that code and I'm gonna explain it instead, so I'm gonna copy those, and I think because this video is running really long. And let's change. All right, so let's start from the beginning. We have a toPicture, we have some list of points. First, we're creating some paint, right? We're just specifying that the cap should be round, the color should be white to match our training data when we draw. The width of it I found to match best when it's around 16, because the brush size or the stroke width of the training data is quite large. So we're going to keep that to a pretty large value. When we're drawing here, the width is very small. It's only 4. But that's because it looks pretty good on the image or the drawing here in the box. But when we're converting it, we want to have a larger one because that's when our model does the best. Then we're creating a background paint, which just has black as a background. We're creating a canvas that we're going to draw on. And we're doing that. This is going to be 28 in size, like that. It's just going to be, yeah, I'm not entirely sure about this actually. This is just going to be a rectangle that's 28 by 28 in size. And what we're doing then is we're creating a recording so that it's going to check what is being drawn on that recorder so that we can then convert that to a picture. So we're gonna have a canvas. It's gonna take in that recorder. It's gonna take in that canvas rectangle as our where we're gonna draw upon, and then we need to scale that as well to be sort of the difference between where our point is from, right? Where we have a when we're drawing inside this, it's 300 by 300, but the output is only going to be 28. So we need to scale everything by 28 divided by 300. Then we're gonna draw a rectangle which has background paint that is black. Okay, now on that canvas, we're gonna do the same thing as we did before. We're gonna go through each point and we're gonna draw the line with white paint. And then at the end, we're gonna return recorder.endRecording. Okay, all right, this is a lot to take in. Let's see if we can now get this to work. Specifically, we need to change this right there. So we need to create this to an asynchronous function. We need to set state, and it's going to just set the state of that digit. So just set state. And now let's see if this works without rerunning it. So we draw. Hey, oh, this is not good. This needs to be when we press that thing. Digit needs to be set to -1. So we need to do set state. And then it's removed. So let's do a 1. It's a 1. Let's do a 0. Oh, that's bad. The model is not that good, yeah. Let's do a 0. Let's do a 2. All right, yeah. Now let's do a 3. Yeah, all right, that's pretty good. yeah, all right. So we built the entire app. Also, I think that when we create the container here, we should actually add, I guess, 2 times 2, 2 times 2, because the border is actually taking up 2 pixels here and 2 pixels on the other side. So the thing here is actually not 300 in size. So we should make this a little bit larger to compensate. And then this will actually be 300. And yeah, so now we also get to the point where deploying an app is so completely different from just training a model to do well on Mnist. And let me explain why. So when we take an image, for example, here, this has a black background, but a white digit, right? When you're drawing on paper, that's not exactly how it looks like. You probably have white background and a not black, but maybe a gray digit. So you would need to do augmentation to be able to train on that as well. And then also, perhaps when you're drawing, you're not drawing with this large of a brush size, right? Maybe it's much more smaller than that. So how would you create a model that can do well on smaller brush sizes as well? Additionally, every image in Mnist is centered. So for example, if we draw a 1 here, that's going to be a 1. But has it seen examples where a 1 is drawn here? No. Has it seen a 1 when it's drawn here? No. So what we would have to do is create some type of augmentation to cover where we have it on, oh, that worked. When we have it on different parts of the image. Perhaps that's not too difficult as well. We could, create a padded background that's black or something, and then we can just resize it and place it at random points on that image. And then, so let's write those up. So those are sort of some challenges, ways to make the app better. And notice that the ways to make the app better now is actually coming from the model. We've created the app, so it's done. But we now have to make the model better. We need to iterate on either our data set or our augmentation and so on. So what is the major? It needs to be able to grade black digit and white background, right? Easy. I'll write a question mark because things that we think are easy turn out to be more difficult than they seem. But let's just say that's easy. Then we need to be able to have digit in different part of the image, corners, etc. And let's say that, I don't know, easy question mark. I'm not sure. These are sort of challenges for you to try it out. And if you manage to get that, train the model and then do a pull request, and we'll update the app, and it'll become better. So what else? Different brush sizes. More difficult, perhaps. I'm not sure how you would do that. I would have to think a little bit about that. But then also, perhaps the most interesting thing then is, what if I want to draw, 2 digits next to each other? It doesn't recognize that. So the question then is, can we extend to multiple digits, right? That would be interesting. So suddenly, this very simple, perhaps in the beginning, or at least when I was doing this, I was like, oh, this is going to be easy. Turns out to be more difficult than you initially think. And that's because deploying is vastly different than just training a model on Mnist. I need to adapt it to these different scenarios and different cases and so on. So those are sort of some challenges to make the app better. All right. The next step, the last and third step of building our app is to release it to the Play Store. And so the reason I'm doing it to Google Play Store is because I'm using Android and I don't have a Mac to publish it on iOS App Store. So that's what we're going to do, and hopefully you also use Android. If you use Mac, then you should be able to adapt it as well, but you might need to do some additional steps. I'm gonna go to this page, flat icon, and what we're gonna do here is we're just gonna search for a number, and I'll just pick this one because I like that one, and we'll just download this PNG, so free download. And it also says here that attribution is required, and so all we have to do when we upload the app to Play Store is add this right here, that the icon was made by this guy. We're gonna take this image, and so I downloaded it, copy that. Then what I'm gonna do is put it into, let's see, on our desktop, hello Mnist. We're gonna take it into the assets. So we're gonna change that to icon. Yeah, and then we're gonna go back to our app right here. And so what we're gonna do is use this package that we put there before. Now we're going to actually use it. So we're going to do Flutter underscore icons. We're going to do Android equals true, iOS false, because we're not going to do iOS. And then image path assets icon.png. And then I might do a video in the future just how to do it on iOS, but I don't have a Mac right now, so I can't do it. But anyway, image path like that. We're going to do pub.get. Okay, so then in the terminal, we're going to go in the terminal right there. We're going to do flutter pub run flutter underscore launcher icons, and then main. So what this is going to do is it's going to change the icon of our app, hopefully, if it works. So let's see. All right, and now it works. Yeah, now it has that icon. Okay, so now that we've changed the icon, we also want to change the name. So for that, we're going to go to Android app source main. All right, so that's Android. We're going to go to app folder, main folder, and then it says right here Android manifest. And then here it says Android label. We're going to change that to hello Mnist. And now we're ready to go through all the steps we need to build and release an Android app. So first we add a launcher icon. We've already done that. Then we need to sign the app. So first of all, you run in your Android app in the terminal, you run flutter doctor and then v. So that's going to tell us where we have our Java binaries. So we're going to copy that. We're going to do a notepad. So we're going to copy that. And then we're going to copy what they gave us here. I'm going to put the link in the description. And then we're going to replace this Java with, what did they say? Let's see. Key tool. So key tool. We're going to make this into a string, and we're going to put that instead of key tool right there. So we're going to give the absolute path. Then we're also going to change this right here where it's going to be stored. And it's going to be stored at C users, alad, and then key JKS. So we're going to copy that entire thing. And now we go to command prompt, and we just copy paste that in. Now when we do that, it's going to say enter key stored password, and just do your password. So test 1 2 3. Right. Yeah. So I need to remove the previous one I had. All right. So again, test 1 2 3, test 1 2 3. We can skip first and last. So you can just press enter if you don't want to show those. And enter. Okay, what is your first and last name? It's correct, yes. And then it says enter key password, and we'll just have the same as the key store password. All right, now if you go to that folder, you'll see that you have a key.jks. That's the file that was just created, the key. You are now going to create a file in Android that's called key.properties. So let's copy paste this. We're going to do new file, key.properties. We're going to copy paste that thing they gave us, and we're just going to write our password here. And this is going to be test123, test123, and then the location of the key store file. So that's going to be right here, like that. Now that we've done that, we can go on to the next step, which is in Android app build.gradle file. We're going to add these 4 lines. So add code before the Android block. So Android app build.gradle. We're going to go down to Android. Is that it? Yeah, that's it, I think. Oh, it should be in that, I think. Let's see. Add before the Android block. No, okay. So it should be right here. And then add code before the build types block. So here we have build types. We're gonna add this build types right there. We're gonna add these lines, and then we're also gonna change this signing config dot.debug to .release. So they also did that between these 2 steps. All right, and that's it. Now we should be able to do build our app now. One thing is that you might want to change some stuff if you want to have an internet connection and so on. In the next app that we build, we're gonna have need to change these, but for now we can just ignore that stuff. So it says that you may need to run Flutter clean. So let's do that. Let's do that right there. Flutter clean. So Flutter build build app bundle. Key store file. I think that's in the key.properties. We should not have this that last thing right there. So if we now try to do it again. All right, so we built our app, and it's about 22 megabytes, and it's in the, what did they say? It's in the build app outputs bundle release. All right, so let's go to that. Our desktop, hello Mnist. It's in our build app outputs bundle release and app release. So there it is. All right, so the next step when we have that is we're gonna go to Google Play Console. All right, so when we get to that page, it's gonna say create app on the bottom right. So we're gonna top right. So we're gonna create that right there, and now I can zoom out. All right, so we're gonna the app details. It's gonna be hello Mnist, a simple digit identifier. The default language is English. It's gonna be an app. All right, so it's a free app. The app meets the developer program policies, sure, accept US export laws, create app. All right, so then we get to this. We need to set up your app, and then we're gonna release our app. So first we need to just go through all of these steps here. All functionality is available. Then we need to go back to our dashboard. We need to take the next step, content rating, email address, and let's just write my email address. And category, I guess this is a utility tool. Next, it does not contain violent material. It does not, we're just going to write no to all of these because the app is not violent in any way. Save that. Next. Yeah. Submit. Then we're going to go back to our dashboard and we're going to go to target audience. You must complete the ads. All right, go to ads. No, my app does not contain ads. Then app content. We need to add a privacy policy. And what I've done for that is I Googled privacy policy for app, and there's a policy generator right there. And you write in your app name, and you also write in what kind of personal identifiable information you might collect. In this case, we're not collecting any, so you can just keep this empty. And then you get a terms of conditions, and you also get a policy. And if we do that, I've already done that. So this is the thing we get. So I've just put that on GitHub. So we get a privacy policy and we get a terms of condition. So I'm just going to copy the link to that GitHub page, and then we'll add that. So save, and then we'll go back to app content, target audience, and everyone can use our app. So it includes children. We do not collect any personal sensitive information. Next, I'm not really sure what Design for Families program is, but I don't want to join that. Save. A news app. Is your app a news app? No. Save. App content. And now we've done all of them. So then if you press dashboard, we'll go back to this. We'll select an app category, and the app category is going to be education, I guess. Education, we'll write the email address again. Save. We'll go back to the dashboard. Set up your store listing. And then this is the name. Short description of the app here, and then a longer description of the app here. Save. Oh, yeah. Then we also need to add the app icon, which we put in our assets. So I'll just drag that over. Then we also need to have feature graphic. I've already created those actually, but this is I've just created hello Mnist, and that's it. It needs to be 1024 by 500 in size. And so we'll just drag that right there. That's our feature graphic. Then we want to have some phone screenshots. So that's why I've taken these two right here. And I've just screenshotted the emulator phone from the when we run the Android Studio, run the app. So then I'll just drag those two over there. And we just need 2 phone screenshots. And then that's fine. We'll save that. And we'll go back to the dashboard. And now we're going to go to, we can do open testing. So let anyone sign up to your test app. First, we'll select the countries and we'll add countries. We'll add all of the countries. Add countries. We'll do release. We'll create a new release. And what we're going to do is we're just going to, Google is protecting your app signing key. All right. Then we're just gonna take that thing that we let's see. So when we go to build app outputs bundle release, we'll just drag that right there. That's our app bundle. And we can call this initial release. Enter notes here. All right, so this is one thing I forgot to do. We're using the package name that is the ID of the app essentially is now using com.example, but we need to use another package name. So how we do that is that we go back to our app here, and I added this package before, change app package name. So what we do is, let me bring that on that. So we're gonna do Flutter pub run change app package name main, and let's just do com dot my app package dot hello Mnist. I mean, you can really name it whatever you want. So we'll run that, and then we'll do Flutter build app bundle once again. All right, and that seemed to work. So what you'll do now is just save that, review release, and then you would press start rollout to open testing, and that you would then need to wait for a couple of days, I think, before they would review the app, and then it's published to the App Store or Play Store. All right, I think that's it.